Hey Titans, this is Mr. Sturts. We're going to talk about how to add and subtract radicals now that we know how to simplify radicals. Before we start, just a quick review of adding and subtracting with variables. Remember, we can add and subtract like terms. So if we have 2x and 3x, 2x plus 3x is 5x. 7x squared minus 4x squared, that gives us 3x squared. If we have 4x plus 3y, those aren't like terms, so we can't add those. So we just need to leave it as 4x plus 3y. Now when we get to radicals, what we see here, we have 3 times the radical 2 plus 4 times radical 3. These are not the same radicals, so just like with variables, we can't combine these. So we have to leave it as 3 square root of 2 plus 4 square root of 3. We can only add and subtract like radicals. Okay, so that's what we're going to work with today when we're working through these adding and subtracting problems. Okay, so a couple examples here. Let's say we have 3 radical 2 plus 5 radical 2. First question we got to ask, are those like radicals? They are. They're both radical 2's. So all we're going to do is we're going to add the numbers before the radicals. So what we have is we have 3 radical 2's plus 5 radical 2's, which actually gives us 8 radical 2, or 8 times the square root of 2. Okay, so maybe a subtraction example. If we have 5 square root of 3 minus 2 times the square root of 3, they are like radicals, so we can subtract them. So we have 5 square root of 3 minus 2 times the square root of 3, which is going to give us 3 times the square root of 3. Okay, maybe something else that might pop up that could create a little confusion. If we have 4 square root of 3 plus just the normal square root of 3 with no number before it, really what we're going to assume, just like if we have a normal x, we're going to assume the coefficient, the number before it's 1. So in this case, we just assume that there's a 1 because it's 1 times the square root of 3. So we have 4 square root of 3 plus 1 times the square root of 3, which is actually going to give us 5 times the square root of 3. Okay? Now, let's make it a little bit tougher here. Let's combine what we did with the simplifying radicals when we're adding and subtracting radicals. Okay, so an example here, if we have 5 square root of 3 plus 3 times the square root of 12. Okay, we can't add those. They're not like radicals. Okay, but what we can do is we're gonna look and see if we can simplify either of these two radicals. Radical 3 is prime. We can't simplify that. That one's in simplest radical form. But if we look at the square root of 12, let's try to factor tree that. We know 2 goes into 12. Let's use 2 and 6. Okay, 2 is prime. 6, well, we know 2 times 3 is 6, and we circle those. Remember from simplifying radicals, remember what we did. We put those underneath the square root, so we have 2 times 3. This 3 was already out front, so we're going to write that right out front of the square root. Remember, we're circling groups of 2, and for every 2 we circle, 1 comes out front. So we have 2 2's here. For every 2 that we circled, we brought 1 out front, and remember, we multiplied it with that number out front. So we brought 1 2 out. Well, we have 3 times 2. That's going to give us 6. Okay, remember, the other one goes away. And then what we have left is the square root of 3 underneath. Now, 3 square root of 2, or 3 times the square root of 12, in simplest radical form is 6 radical 3. So what we're going to do now is we're going to bring down this 5 radical 3. Now, they're like radicals. We can add them. 5 radical 3 plus 6 radical 3 gives us 11 radical 3. Okay, so we're going to look to see if we can simplify if we can't add or subtract. All right, let's do one more. Let's do a big one here that combines kind of everything. This one's going to have 3 separate terms. We're going to do 3 radical 12 minus 2 radical 18 plus 6 radical 27. Okay, no like radicals here. So we're going to look to see if we can simplify these, which we can. Okay, the square root of 12, the radical 12, if we go to factor tree this, if we use our 2 and 6, 2 and 3 again, these are our prime numbers. We're going to circle them. So what we have then, we have 3 out front, 2 times 3 underneath. Let's leave that for right now. We'll come back to it. Now we have this middle term minus, now we're going to look at this. It's really three problems in one. Can we factor tree 18? I believe we can. If we use 2 and 9 and 3 and 3, here's our prime numbers. Okay, let's do just what we did on the first one. We write the 2 down because that's what was out front. Underneath the radical, we have 2 times 3 times 3. 3. And then plus, let's solve this one, the square root of 27. What goes into 27? Let's use 3 and 9, and then 3 and 3. Those are all prime numbers. So same thing here. The 6 is out front. We got the 3 3s underneath. Now we're almost done. Okay, we're going to circle our groups of 2 underneath. We're going to simplify these radicals. So we got 2 2s. Remember, 1 comes out front, and we're going to multiply it with the 3. So we have 3 times 2, which is 6. The 3 is left over. It didn't have a partner, so it stays underneath. Minus, same thing here. We can't circle these because they're not the same, but we have 2 3s, right? So we can bring 1 3 out front and multiply it with the 2. So 2 times 3 is 6. And we have a 2 left underneath the square root. Plus, we have 2 3s. So we're going to circle 2 3s, bring 1 out front, and multiply it with the 6. So we have 18. 6 times 3 is 18. And we have the square root of 3 left over. Okay, now let's look. Do we have any like radicals now? We do. Okay, we have a radical 3 and a radical 3. So what we can do is we can do 6 radical 3 plus 18 radical 3, which is going to give us 24 radical 3. We don't have any like terms with this middle term, so what we're going to do is don't forget the minus. That's attached to it. Okay, so it's going to be minus 6 square root of 2. And we simplified that expression there. Thank you for watching.